Good morning everyone. I am Suguna Selvarani, Assistant Professor, Department of Mathematics, CPA College, Bodinayakanur. Today we can see about some basic definitions of graph theory. First, definition of a graph. A generalization of the simple concept of set of dots, links, edges or arcs is called a graph. It is represented as set of v, e that consists of set of vertices denoted by v r by v of g and set of edges is denoted by e r by e of g. Next, we have some types of edges. First one is directed edge. If the edge is represented with a direction, then it is said to be a directed edge. And if it is not represented with a direction, then the edge is said to be an undirected edge. That is, in the first example, we have an direction for the edge. It is represented from u to v. Okay. So in the second example, we have no direction between u and v. So it is said to be the edge moves from u to v or from v to u. Next, loop. A loop is an edge whose end points are equal. That is, an edge joining a vertex to itself is called a loop. Okay, or multiple edges. Two or more edges joining the same pair of vertices is called a multiple edge. Next, a simple graph. If a graph has no directed edges, then it is said to be a simple graph. So here we have a graph with 3 vertices and 3 edges, but any of the edges is not represented with direction, so it is a simple graph. Multigraph. If a graph has parallel edges, then it is said to be a multigraph. So here we have 3 vertices and 3 edges, but the edges E1 and E2 are represented between the same pair of vertices U and V. So we have parallel edges here. So this graph is a multigraph. Next, pseudograph. If a graph contains multiple edges, that is parallel edges or loops, then it is said to be a pseudograph. So here we have a graph with 3 vertices and 4 edges, but we have E1 and E2 are represented between the same pair of vertices U and V. So we have a multiple edge here, and also the edge E4 is represented from W to itself. So we have a loop here. So this graph contains both multiple edges and loops. Then this graph is called a pseudograph. Directed graph. If all the edges in the graph are directed, then it is said to be a directed graph. So here we have 3 vertices and 3 edges, and all the 3 edges are represented with a direction. So this graph is a directed graph. Next, directed multigraph. So we have multiple edges, loops, and also the edges are represented with the direction. Then this is a directed multigraph. So we can see about some terminologies for undirected graphs. U and V are said to be adjacent if there is an edge between them. The edge E is said to be incident with U and V, and U and V are said to be the endpoints. Okay. So degree. A degree is said to be the number of edges incident on a vertex, and here a loop contributes degree 2 to a vertex. If the degree of the vertex is 1, then it is said to be a pendant vertex. If the degree of the vertex is 0, then it is said to be an isolated vertex. So here we have an example. So we have 4 vertices and 2 edges. So here the degree of U is 2 and degree of V and W are 1. So they are said to be pendant vertices, and degree of K is 0. So it is said to be an isolated vertex. Next, terminologies for directed graphs. In degrees. If the edge is directed towards a vertex, then it is counted as in degree, and if the edge is directed away from the vertex, then it is counted as an out degree. So here in this example, we have 2 edges directed away from U, so they are said to be out degrees, and we have an vertex 2 edges directed towards W, so they are in degrees for W, and for V we have 1 edge is towards V and 1 edge is away from V, so you have 1 in degree and 1 out degree. Complete graph. if there is exactly one edge between each pair of vertices, then it is said to be a complete graph. Okay, so we have K1 and K2, K3 and K4. Okay, so see, we have all we have edges between each pair of vertices, then it is said to be a complete graph. Cycle, a cycle must contain at least 3 vertices, that is n must be greater than or equal to 3. That is, in a cycle there must be an edge between each pair of vertices with v1 to v2, v2 to v3, etc., and from vn to vn. That is, it must be a cycle. Bipartite graph. In a simple graph G, if V can be partitioned into two disjoint sets v1 and v2 such that every edge in the graph connects a vertex in v1 and a vertex in v2, then it is said to be a bipartite graph. Complete bipartite graph. KMN is the graph that it has vertex set partitioned into two subsets of m and n vertices respectively. There is an edge between two vertices if and only if one vertex is in the first subset and the other vertex is in the second subset. Then it is said to be a complete bipartite graph. Subgraph. A subgraph of a graph G is equal to V comma E is a graph H is equal to V dash comma E dash, where V dash is a subset of V and E dash is a subset of E. That is, if a graph can be created with some vertices and some edges from the main graph, then it is said to be a subgraph. So here, see, G is equal to a graph with U, V, W, and then we have 3 edges in between them. So if a graph H1, that is, a graph is created with 3 vertices and only 2 edges from them, then it is said to be a subgraph of G. So similarly, we can create the next subgraph H. It consists of only 2 vertices from the main graph U and V and only 1 edge from the main graph. So this is also a subgraph for the graph G. So that's all about this definitions of graph. So thank you.